So the key features are all listed here. So you've got your labeling with units and uncertainties. You need to make sure that error bars are present. If they're not present, if they're too small, write error bars are too small to be seen under the graph. Make sure the increments match, the plus or minus increments match the grid lines, so you can read to the accuracy of the plus or minus. So you can see these ones go up in 0.4s, as it is plus or minus 0.4s, and these go up in 1s, that's plus or minus 1. It can be more detailed than that if you wish, which will be in the practice graph next. And the R squared is important, but you can't just do multiple polynomials until you get a perfect R squared. So if the scientific theory is this increasing and decreasing rate or linear or whatever, then you're allowed to do the line for that equation, and then you can use the R squared. All right, so just going to a practice one now. So hopefully you've done the practice raw data and created this graph. And if not, you can just grab the numbers and just create one anyway, because we're only using 5 numbers, 5 versus 5 anyway. And so what you do, it's kind of easy once you've got the graph. So we're doing the independent versus dependent, so it's the concentration here. So I hold down the control button, and that allows me to grab something from somewhere else without grabbing everything in between. So I'll hold down the control button and then insert scatter graph. Now, if you're not doing continuous data and using a scatter graph, well, make sure your method is, don't do discontinuous data with bar graphs. So that is a bit late now, I guess, if you've got something weird going on. And so there we go. Now, before you do anything, always go to this quick layout and get as many grid lines as you can. Because if you're lucky, there'll be sufficient grid lines and you won't have to play with that later, but I'll have to show it to you anyway. Let's just get the correct units in there so we can see what the number of grid lines are. So unfortunately, as you heard from the last one, that the subscripts and so forth probably don't carry over. And no, they don't. So I have to still do that, unfortunately, and make that the proper subscript, which is probably the thing that annoys me the most with all these ones. So concentration and initial reaction rate over here, and I'm going to have to do that a few times for this one. So I'm going to have to grab the -1 if that's possible, and do a superscript on all of them. What else do we have there? We've got a -3 in there somewhere. It's a bit hard to do it backwards, but we'll manage. And I can't see anything else. There we go. There's a 3 in there. Okay. Now, that's all a little bit small. Let me just make this a bit bigger so we can read it. We don't need this bit. Let's get rid of it. That's much better. Okay, let's work with that. And so let's just correct the units first. So there's no uncertainty for this because we just took it as the correct volume from the tech. If you made your own dilutions, that would be 1. We've definitely got a 0.6, and this is going up in 0.1s, so we're all good. So it's accurate enough. And so now we just need to do the line of best fit. Now, this is either a straight line or a curve. I think the published value is a straight line, so we're going to go straight line. And it'll go through 0 because when there's no concentration, there's no reaction. And so we're allowed the R squared. We can do the, we can also do the equation of the line. And so that's the relationship there, and it's not too bad, 0.9777. So the only thing we need to do now is finish off the error bars. So I'll just do add error bars. Oh, and sorry, if you did need to change these, you double click on this and go to here, and then you can increase or decrease the units. So I could ask them to be a lot bigger, like 0.5s, which would actually be okay. And that goes up. It still has the minor values in there. I'll just do a Control-Z on that. But if you click on these things here, you can change these values. I don't know what I did there. I want to go back. And so here, like, see if I can get a 0, 1 in there. Super fine. Yeah, you have to zoom in, but they're a super zero fine 0.1s, which is a bit extreme. So I'll just take that back and get rid of it by pressing Control Z a few times. So hopefully you've learned how to do that. The other thing you need to do now, I'm going to do a very simple uncertainty because it's always 0.6, but there'll be times when you want to do, most times actually, where you want to do uncertainties that are unique. And so say this one's like a massive one or 2, and then most of them are just okay, and they're like 0.3 and 0.3 or whatever. I'll just show you how to do those ones first because it's slightly harder. So we do error bars here. So add error bars. Now we don't have ones for these ones here, so we delete them out. And for these ones here, what we do is double click on that, and it's custom. So we specify the value, and we want it to be these values here. Is that a 0.2? I hope so. That might be doing something weird because that point, I don't know if that's a 0.2 or not. And I didn't do that right because I had to do the bottom ones as well, which I didn't. So I delete that one out, and I put the minus ones in as well. Okay, now that middle value should be massive, and because that's what we're trying to show. And I screwed that one up with a comma, but that's just to illustrate a point on how to do individual ones. All right, so I'll just press Control Z and go back because ours are pretty easy. We've just got to get them to be a set value. So go to here and just do a fixed value of 0.6. And that's fairly easy for that, which is nice because the line of best fit goes through all the error bars. Okay, and so that's your finished graph. Okay.